Hey guys, so I wanted to do this video real quick just to kind of give you an idea of what is it that I want on this. This is not supposed to take you a really long time. Of course, you can put some of these graphs into Desmos, if you will, so you can get a general idea what they look like. But by the end of it, however you decide to do it, you're supposed to have some intuition of how this works, okay? So for example, here's what you need to know. All of these functions are either going to look like, I guess let me go back to your notes so you can see what I'm talking about. So take a look at your notes. They're either going to look like this. If the bottom of the function is an odd function, an odd degree, excuse me. So by that I mean if this is, power of 1 or power of 3, or power of 5 or anything like that, it's going to look in general, not exactly, but in general, it's going to have this general shape, okay? Now, if the denominator of that rational has an even degree function, like an x squared, x to the fourth, x to the sixth, or anything like that, it's going to look in general like this. Now, remember that this green line that you see in the middle is not really there, okay? So it's either or, all right? Now, some points that are key, I think, for all of you, are the points that I have with an arrow here, -1, -1, 1, 1, or 0, non-defined, and the same numbers for the even degree function on the bottom, that is. So these are the numbers that you may see me kind of mess around with, okay? So let's go to the homework real fast. So for example, here's what I'm trying to say, all right? So number 2, this is on the bottom, this is an odd degree function. It doesn't matter, don't expand it, I don't expect you to do that. But in general, that's going to look like this function, 1 over x plus 2. Now, what you do need to know is that x plus 2, you can set that equal to 0. And when it gives you that answer, which is x is equal to -2, that actually tells you how much to move the graph, right? So this graph will look kind of like the graph 1 over x, but it's going to be moved to the left 2 spots, all right? So you can kind of see me do the dotted line right there, and then I graph it, okay? So let me actually do one live for you. So actually, you can kind of see the answer here, but in essence, the reason I know what I know about this graph without actually even looking at it is that I know, for example, that if the number is on the outside, all right, notice that this is different than the last one. If the number is on the outside of the function, that's going to move it up or down. So in this case, the function is going to be moved down 3. Now, what is this going to look like? Well, let's look at it, okay? This is going to look like, because this is an even degree function in the denominator, in general, this is going to look like something like this, all right? Now, remember the key word is in general. It's not going to look exactly like this, but pretty close. Okay, now what happens when I move it down 3 is that those 2 red lines that you see there, or red curves, they're going to move down 3, all right? So in order for me to do that, I'm going to draw, I'm going to put my fake origin right here in the middle. Now remember that little cross right there is not really in the graph. I'm just using it to help me graph the function, okay? So now the other thing that's going to mess with my graph is this negative. If I have a negative, just like the previous stuff that we know from functions, that's going to make this a reflection over the x-axis. Okay, so essentially what you see there in red is going to get reflected. So for us, okay, and I can put those 2 points there, that is going to be a reflection over the x-axis. Of course, that's what that would look like, okay? Now let's talk about domain and range real quick. The domain for this one. Remember, the domain is defined as what are the x values. Now in this case, it would be easier for you to figure out what x cannot be equal to. And in this case, x cannot be equal to 0. Remember, 0 would be this line right here, this right there in the middle. Okay, so and, remember that letter U means and. Now for the range on this one, I'm going to go between negative infinity. I'm going to go all the way as high as I could, which in this case is only -3, right? And it does not include -3, therefore you have that parentheses, right? So, and again, if you look on Canvas, you can actually see the answers, what it would look like, and you can see the minus, the graph particularly is pretty close, okay? All right, so let's take a look at one more, maybe an even one. Don't forget, for example, this one right here, number 7. I'm not going to do it. You can definitely look at the answer on Canvas because this is an even function. It's going to look similar to what I did previously. And on this one, x is equal to 1, which means I'm going to move my graph to the right one, okay? Now let's look at number 8. Number 8 is not, it's obviously not going to be in your canvas because it only gives you the odd answer. So in this one right here, right, the main thing to understand is that, first of all, x plus 1, this graph in general, because this is an odd degree function, an odd degree function on the bottom, it would look more like the 1 over x function, okay? Now the 1 over x function, whose parent function, whose points or relevant points is what you see here, would look in general like this. Now, of course, the cube is going to make these points be a little bit different, but in general, that's what it's going to look like, okay? Now, that too is actually going to make this like a vertical stretch, but this would be pretty hard to do vertical stretch on this. Now, finally, remember that x plus 1, if it's on the inside, set that equal to 0, and you get x is equal to -1, which means I'm going to move my axes to the one to the left, and then now we're going to graph it. Now, it's going to look exactly the same. You don't have to overthink it. You don't have to give me a table with all these numbers, because at the end of the day, these numbers are going to be very small, very quick as you go through these, okay? So in general, you need to just give me what that would look like. And in this case, this is the shape that it would look like, okay? You can see the domain and range there. And finally, for number 9, for example, I can tell you that this is reflected. I know that I'm going 5 to the right. And I'm not actually going to graph it, but hopefully you get the idea. This is not supposed to take you a long time. Now, if you need to look at Desmos to see what's going on, so you can create some intuition about how these graphs work, that's okay. Do that, okay? But by the end of this homework, you should have a general idea of function transformations, which, if you think about it, is exactly like the other transformations that we've ever done. It's just a different function. Okay, so I hope this helps. Make sure to have this done by the time I see you.